Hi, this is Dr. Pan, host of Tucson Math Doc channel on YouTube. We have a very nasty and complicated function here to find a derivative of. One thing we will be using for this particular problem is that arctangent of x. When we take derivative of this one, that's equal to x over 1 plus x squared. It's not a very common one we use, but we will be using this one. Now, one thing you do notice that it's in the form of exponential. That screams use natural log, or most people don't use log anymore, but we will be using natural log over here. The reason we use natural log is before you take derivative, you've got to get this exponential down in the front into the multiplication, because we don't have rules for exponential function to have derivatives. Okay, so let's get started. Let's replace this one with a y to make it a little simpler. So we have natural log of y on the side is equal to tangent arc 2x times natural log of 1 plus x to the fourth. Okay, that's the first thing we do. And then we're going to take derivative. It's a little bit implicit differentiation that in that we know y is a function of x. So take a derivative from natural log of y, that's 1 over y. But we do have to do dy dx because it's a implicit differentiation in that y is a function of x. This one is equal to, now this side we're going to be using the chain rules, because product rule first. Derivative for the first one, that's 2x 1 plus 2x squared, and then I need a times 2 because this is my chain rule taking place. This one is a function of x. So the derivative of the first one times, leave the second one alone. Okay. Add, now I tell my students, if you run out of room on this side, there's no reason to squeeze it over there. Squeezing in math, it's not a good idea. All right, so second one is plus, leave the first one alone, which is arctangent of 2x, times derivative of the second one. It's natural log, so it's 1 plus x to the fourth. And then I do have to use chain rule again. It's 4x to the third. Okay, now we're almost there. We are looking for dy dx. We're going to have to multiply by y times this whole thing over here. Okay, let's just call this a box of A. Okay. On the test, I ask my student, you run out of time, show me what you're trying to do. So I'm going to put an A over here, then I'll put A later on, everything in there after I figure out what I'm doing or the steps to show the bigger picture first. Okay, what is y? Y we were given is at 1 plus x to the fourth, the whole thing to the arctangent of 2x. Okay, now here's where I'm going to put everything in again. What's A? Is whatever I had before. So it's a 4x. Okay, 1 plus, I'm going to just write it as 4x squared. I multiplied it out. Times natural log of 1 plus x to the fourth. Okay, plus tangent inverse of 2x. And then I have a 4x cubed on top divided by 1 plus x to the fourth. That is indeed a very messy one, but here's our answer. Dy dx is equal to this. All right, hope this helped. Have a confident day.